All right, so let's see here. I guess we'll just do them in order. 31's right here. Altitude expands as it rises due to the. Suppose that the radius increases at a rate of 0.03 inches per second. So that would be a formula for that. And that the radius is 48 at time 0. 48 at time 0? What the heck does that sound like? Sounds like a y-intercept to me. Because the time is 0, therefore you have a radius of 48. So you're starting at 48 and going up by 0.03 every second. So that's what they meant by giving you that information. Determine an equation that models the volume V of the balloon at time t. Okay, well we know that volume for a sphere, 4/3 pi r cubed. What shall we do? We want V on one side and T somewhere on the other. We don't want an R anywhere. Yes, sir. Is that what you were going to say? Yes. That is exactly what we need to do. Substitute. Oh. By the way. All right, now we got our substitution to the third power, 0.03t plus 48. Do you think I want to take that binomial and raise it to the third power? Do you think I really feel like doing all that work? I don't think so. All right? I think we'll just stop right there. Okay? Because that would be a nasty, ugly mess to try to multiply all that out. Okay, determine an equation. All right, we did that. Find the volume when the time is 300. So obviously, for part B, they're asking you to plug in a 300 in there and go from there. So I will leave that into your capable hands for question 31. And now we shall clear that out and work on 33. A satellite camera takes a rectangular shaped picture. Okay. The smallest region that can be photographed is 5 kilometers by 7 kilometers. Okay, wow. As the camera zooms out, the length L and the width W of the rectangle increase at a constant rate of 2 kilometers per second. How long does it take for the area to be at least 5 times its original size? What was the original size? 35. Good job. All right, now we're going to a larger size rectangle, right? 2 kilometers per second. All right, so we're at 5 and we're increasing 2 kilometers per second. All right, and that would be 7 plus 2t. What do you think we should do with the 5 plus 2t and the 7 plus 2t? Multiply them together. Awesome. Now, some of you are probably like me. You are boxers. Others of you cannot stand it. So if you can't stand it, shield your eyes. I'm a big fan myself, but you may not be. 35, we got a 14t, we got another 10t, and a 4t squared. So 4t squared plus 24t plus 35 equals what? One what? 175. Thank you very much. Okie dokie. How long does it take? What do you think we should do? Solve in what way? Thank you. You mean subtract 175 to the other side? Sure. That's a great idea. 4t squared plus 24t minus what? Is that minus 140? Ooh, I see a GCF, I think. Is there a GCF in town here? What can we pull out? 4. And that would leave me with t squared plus 6t minus, ooh, is that 35? I believe. Are you kidding me? That's not going to work. Can we factor that? I don't know factors of 35 whose difference is 6. Man, I thought we had something pretty cool here. Well, we kind of do. We could graph this, couldn't we? Figure out where it crosses the x-axis. Because one of those has got to be the answer here.
You could also use the Pythagorean.
I would have to think about how you're going to do that.
Isn't that the one where it's b squared plus...
Oh, no, you meant quadratic formula.
Okay.
Yep, quadratic formula I totally agree with on that one. But if I want to graph this, first I better change my mode back to function. And then x squared plus 6x minus 35. Okay, so I better clear this out. Well, that ain't it, Chief. Oh, gotta plug it in. Yesterday I learned what the plural of hydro flask is. I heard it from a kid. I was like, what is it? He said, hydro flasks. I was like, nice. I was like, man, that was intelligent. I liked it. Way to think. Did you get some sort of picture that looked like this? It's a horrible looking parabola, isn't it? Is the information that I need looking at you on this screen? Yeah, I'm looking at the zeros. In fact, which of the two zeros do I even need to worry about? That positive one. So if I do second calculate 0, if I come over here to the left bound, I could do like -2, or even +2 would have worked. I guess I was thinking +2. I don't know why I said negative. I don't know, 6. As long as the 0 that you're looking for is in there, boom. Looks like 3.63 seconds. Yes, you could use the quadratic formula to do the same thing. That's another way to handle it. So, what if I do undo? Yeah, okay. So 3.63 seconds. So, either graphing or using. All right, let's get into 1.5. That's not what I wanted. All right, we're good. Okay. In the last example of section 1.4, which we also kind of emphasized in question 31, there were two equations that had a common variable, and we took that common variable and tied those two equations together. That is the same idea. Please don't tell me this will keep it later. All right, that'll work. The idea of what we call parametric functions is kind of that same idea. It looks a little bit different from what you're used to. A parameter is an additional variable that we connect two functions together with. Now, what you're going to eventually see is that the connection of those two variables together is a composition of functions, which we talked about already with compositions. Now, take your calculator and hit the, as I mentioned yesterday, the Edna button, sometimes referred to as the mode button. Okay, you should see a whole bunch of stuff on it. Okay, if you're using the old style calculator, you have larger font. Okay. There should be one that says function. Might be abbreviated on the old style calculator. We want to switch our calculator over to parametric. For you, if it's PAR, I believe is what it's abbreviated as. Parametric. When you go to y equals, things look different. You see x1t, y1t, those kind of things. Lots of t. And we would like, let's see if I can narrow this down a little bit. Or if I could do like this. Maybe. Sorry, I'm just trying to see the equations. So x, we want that to be t plus 1. You're using the xt theta n button, the same button that you used before when you were typing x's, will also now type t's in parametric mode. And t squared plus 2t. Anybody having any problems finding or graphing the t plus 1? Yep. Okay. Okay, anybody have any questions on getting that entered in? Okay. Now, above the word window it says table setup. Please go to the table setup above the word window. At the top of the calculator, you see the word window. Right above it, it says table setup. It really doesn't matter what your table start value is. It doesn't matter what your change in table is, because we are going to use the independent variable on ask. Switch your independent variable over to ask. back here. Yes, sir. Okay. Your xt theta n button, which is the one we used prior to on the right, it does t's now because it's in parametric mode. Okay, everybody to this point? Any questions? Right above the word graph, it says table. Right above the word graph, it says table. It should look fairly empty. If you have other values in there, you could just hit the delete key and get rid of them. So, what are they looking for? It says find the points determined by -3, -2, and they're giving me different values of t. That's the t. -3, -2, -1, 0, 1, 2, and 3. You know what? Boom, there they are. There are the coordinates. Any questions on how we find those coordinates? You're really letting it do the work for you. It does all the heavy lifting. Find an algebraic relationship between x and y. This is often called eliminating the parameter. Okie dokie. This is a lot like what you did in question 31 and in example 1.4 or section 1.4 example 5. Pick one of the variables to solve for t. Is there an equation that you think would be easier to solve for t? Which one? Either the top one or the bottom one? That top one, excellent choice. All right, so if we solve that for t, what do we get? Well, there's got to be an x in there somewhere. X minus 1, that's true. Right? Getting t by itself. What do we think we're going to do with this thing? Plug it in. Thank you very much. Are you guys familiar with Glade air fresheners? Not Glad, those are trash bags. Okay. Glade air fresheners. Do they still have the commercial? Plug it in, plug it in?
No?
No? Oh, man. Okay.
They did remake all the way going down the stairs and help us all. I can't get up.
Oh, yeah, they did do that one?
Yeah, they remade it, so now it's just terrifying.
Oh, okay.
It's not funny, it's just terrifying.
Still funny.
No, the next one. No, the next.
Well, in a sick sense of humor,
like
you know.
shrieking, like you dying.
Exactly, that's
Okay.
why it's funny.
Oh, okay. Wow.
Oh.
All right.
That's why it's funny.
Just remember, these things never happen to people. Okay, I need you to simplify this. Simplify this. It is interesting to me the number of people who do not understand how to square something. X minus 1 times itself. Because they get all kinds of things like x squared minus 1, x squared plus 1, instead of what they should get. And then, of course, we've got this part, which you guys are good at. What do you think we should do there? Right. So when you add it together, what do you get? We did get y equals x squared minus, oh man, it went off screen. Sorry, I'm going to have to back myself up here. Y equals x squared minus 1. Look, no t. Right? We've eliminated the t parameter, right? Is y a function of x? Oh, yes, sir.
Where did the -2 come from?
When they told me to distribute the 2 times the x minus 1, see the 2 times the x minus 1 right about here? That's where we got the 2x minus 2 from. Okay, so what is y equals x squared minus 1? Come on, think. What is it? What's it look like? What kind of parabola? Does it open up, down, left, or right? It opens up. It's also been shifted down 1 unit, which really doesn't make a whole lot of difference. Is it a function? Does it pass the vertical line test? Sure does. So that's a big ol' yes. Now, we need to graph. We're in parametric mode, aren't we? Now, in parametric mode, go to the window. The window has some extra stuff in it that you've never seen before. There's a T-min and a T-max. Let's, just for now, let's leave it at -10 to 10. In the future, there will be problems that specify a certain range for T, which means you may not get an entire parabola. You may only get a part of a parabola. In fact, I'm not even going to give you all of a parabola. So, now you think it's the entire parabola. If we would zoom out, you'd probably see that it stops, right? Because my t values don't go on forever and ever and ever. But we can graph in parametric mode as long as you understand what that t step is, or t min, t max. It will change in the future, not necessarily for these problems. Okay? Consider the set of all ordered pairs defined by this equation. All right, so we go into our y equals, we got t squared plus 2t. And then for y, we've got t plus 1. Come on. You know how to do A. What if you jump down to B? Graph it. What kind of shape did you get? What kind of shape did we get? You're going to hold it up from there and expect me to see it? Why can't you just tell me what it is?
It's a square envelope.
Oh, a right side opening parabola, something like that? Is that what you got? Oh, cool. Is that a function? Is y a function of x?
No.
Nope, fails the vertical line test. Right? Nope, fails vertical line test. Find an algebraic relationship between x and y. What are they telling you to do? How do I connect? What are they telling me to do with these two equations? Say it louder. I don't know. Okay. Yeah, but
Get rid of t.
Get rid of t, right? So same thing we did process before. Pick one of the equations that you think is easiest to solve for t. Which one are you going to pick? Second one? Okay. T equals y minus 1. Okay, so what are we going to do with this thing? Plug it in. X equals y minus 1 squared plus 2 times y minus 1. What do you think we're going to get? Y squared minus 2y plus 1, and then of course you distribute. Okay. Just keep in mind, distributing happens, but not to kids under the age of 18. That's a bad thing. What is the connection between example 1 and example 2? They are inverses of each other. Now, remind me back from our Algebra 2 days. What is step number 1 for finding an inverse? Or what is the connection? How do you know two equations are inverses of each other? You switch x and y. That is flat out the way you find an inverse. Switch x and y. And obviously you probably noticed from a very early point, even when you were graphing this doggone thing, that all they did was switch the x and the y. Okay. Got a parabola on the left. Does this pass the vertical line test? Is this a function? Yes. Here's the inverse. It doesn't pass the vertical line test. No, so it's not a function. Does the original pass or fail the horizontal line test? Fails. The horizontal line test can be used on a function to determine not any information about this one, but about this one. So I could look at this graph and say, yes, it's a function, no, its inverse is not. I don't even have to graph that one to know that information. When you switch x and y, this curve right here, see, some of you kids think that this is what happens. You go, oh, that's what happens. No! When you switch x and y, what kind of reflection happens? It reflects across what famous line? Y equals x, thank you very much, right? Slope 1 goes through the origin. Okay, like some walks on the beach, that kind of thing. All right, so it does this, right? This part reflects down and becomes this part. It's not a rotation. So if you reflect that across the line y equals x, what kind of line does a horizontal line turn into? A vertical one. Which is why the horizontal line test can tell you something about the inverse and whether it will be a function or not. Okay, so is this graph a function? Yes. Okay. Yee. 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 Okay. Okay. So passes vertical line test. How about the inverse? Will the inverse be a function? Well, I don't see any place on there where it's a horizontal line is hitting more than 1 point. So I think the answer is ye. Okay, passes horizontal line test. Okay. How about this one? Is this a function? No, right? Okay, it fails the vertical line test. Okay, what about the horizontal line test? That's a pass, isn't it? Right? No matter where you go, you're only so ye again. Oh, ye of little faith. Fails horizontal line. Oh, what am I saying fails for? Seriously? Stop myself.
Yes.
Yes, it fails. That's a horizontal line test. Okay, what about this?
No, just no.
Ooh, that's no and definitely no. Okay, we're failing everything. Okay, fails vertical line test and horizontal line test. One more left. Of course, they want to ruin our day. Okay.
Please pardon this interruption. This is just a reminder that we are having our after-school detention today. The cafeteria, again,
Sounds exciting.
detention will be held.
Vertical line test. Does this pass the vertical line test? Ding, ding, ding. Yes, it is a function. Does it pass the horizontal line test? No. Okay. So the inverse will not be a function. We've got more to talk about. So when you get to those odd problems in the middle of the assignment, like the 13, the 15, the 17, the 19, the 21, we'll talk about what they mean by inherited domain, but you definitely need to be able to find those equations.
Okay. Because I know they drew it, so see you later.
What'd you say?